All right, so this is our third video for Activity 21-2. This is really kind of the meat or the crust of pre-calculus. This is where it gets really hard. The first two videos we were just simply simplifying trigonometric equations. We're now going to start verifying. The difference is simplifying, you have to figure out where you're going to stop. Verifying, you're actually told where you have to stop. So we're going to work try these C through D, A, B, and C. All right, on try these C through D, letter A, we actually have the equation of tangent times cosecant equals secant. Now when we do this, we only mess with one side. We don't move anything to the left, to the right, and you have to figure out which side you want to work. The good rule of thumb for you guys is pick the harder side and work it, because that's going to be the easier path. In this case, I'm not going to pick secant, because I'd have to make secant, I'd have to make that much larger to find a tangent and a cosecant in it. It's easier to reduce than to expand. Here, with tangent and cosecant, I have more options to go to try to find a secant. So let's see if we can do this. First step is just like with simplifying. We're going to go from tangent, we're going to write it in terms of sine and cosine. Well, tangent is nothing more than sine over cosine times, and that's the ratio identity. Cosecant is the reciprocal identity that gives you 1 over sine. All right, from here, well, we're going to multiply our fractions. Conveniently, my signs go away. That's going to leave me nothing more than 1 over cosine. And of course, 1 over cosine is nothing more than what we are looking for, which is secant. This is not like other math where you've done. You actually have to show me your work, because your answer is all of this. It is not just, you can't say tangent times cosecant equals secant, say true, because I already know it's true. That's why I gave it to you. Your answer is all of the work. All right, try the CD, letter B. The equation itself is 2 minus sine squared minus cosine squared, and we have to get that to equal 1. Well, clearly, we are not going to work the side that says equal 1, because then we have to introduce a whole bunch of stuff. But if we do 2 minus sine squared minus cosine squared, we have a lot that we can actually work with. This one in class we went over, and we actually solved it 3 or 4 different ways. I'm just going to simply show you the way that I see how to solve it. I always think of factoring first. I can actually factor a negative out of a negative sine squared and a negative cosine squared. And when I do that, I get 2 minus sine squared plus cosine squared equals. And of course, I don't write my 1 down. I could, because it's just 1, but this implies that the 1 keeps falling down as long as you put your equals there. Well, conveniently, we have seen sine squared plus cosine squared before. That is a Pythagorean identity. That's actually going to equal 1. So we're going to replace sine squared plus cosine squared with 1. We get nothing more than 2 minus 1, which then, of course, equals 1. And that's what we were trying to get, because, in fact, it is a true statement that 1 equals 1. We can go in and fill in our reasons across the board here. And the very first thing we start with is given. That is a problem we are given to show. My very next step I was factoring. I just simply factored it. From my next step, I used a Pythagorean identity. Pyth. That's the only trig step. And then from there, we just did subtraction. 2 minus 1, which gave me 1. All right, try the CD, letter C. This one is not a lot of trig, but a whole lot of adding, subtracting, and reducing. So let's just jump into it. The problem itself is cosine over sine plus cosine minus sine over sine minus cosine, and that has to equal -1 over sine squared minus cosine squared. So we worked this one in class, and as we went through it, a lot of y'all were like, oh, it's just really a lot, it's not a lot of trig, it's what you guys aren't strong at, which is adding and subtracting fractions and some algebra and simplifying. Well, the first thing we have to do is not a trig step. We're already in terms of sine and cosine. We have to subtract our fractions. So we're going to multiply our bottoms, multiply up, and multiply up. When I do that, my new fraction becomes, my bottom is sine plus cosine times sine minus cosine. And my top is cosine times sine minus cosine. Make sure I keep the same type of bracket. Minus sine times sine plus cosine. Pretty big, ugly problem. The next thing that we're going to have to do is we are actually going to have to distribute. We're going to FOIL the bottom here. We're going to FOIL the bottom right here. And then we are going to distribute my cosine to both of these. I'm going to distribute my negative sine to both of these. When I do that, I get cosine times sine minus cosine squared minus sine squared minus sine cosine. That's my top. And then my bottom is actually the difference of two squares backwards. And I'll end up with sine squared minus cosine squared. Well, that's the bottom I need anyway. Well, conveniently, if you look on top up here, my cosine times sine and my negative sine times cosine, when I subtract them, they go away. I'm going to be able to factor right here a negative out. So I'll actually be able to simplify this down to negative cosine squared plus sine squared over sine squared minus cosine squared. Well, this is pretty nice because this just equals 1. It's Pythagorean identity. I now then have negative 1 over sine squared minus cosine squared, which is actually what we were trying to get. So when we come all the way back up here, what we were originally trying to get, which was 1 minus sine squared minus cosine squared, we have negative 1 over sine squared minus cosine squared, which is the same thing.